Welcome to today's battle in the Flutter Clone Wars. To borrow a title from an episode of one of my favorite shows, we're going from Earth to Starbucks. We're going to clone a part of the Starbucks app, more specifically the rewards tracker, and more specifically the stars floating in the rewards tracker. Eventually we'll come back with another video and we'll take our floating stars and integrate them into a full clone of the rewards tracker, but I thought it would be a good idea to break out this particle effect in its own video and then integrate it in a later video. Now before we get started, are you subscribed to the channel? If not, why not? Your subscription can help the channel grow. Just jump down there, press that red subscribe button, maybe even the notification bell, and if you really love these videos, maybe consider joining the channel as well with a small financial contribution. But with that said, let's go figure out how we're going to clone this thing. The first question, as always, is what kind of thing are we building? From a Flutter perspective, we ask some questions. Do we have any custom layout, for example? Do we need to size and position children in unique places? And in this case, no, we don't. We don't have any children. Do we need to recognize any special gestures, anything that a gesture detector wouldn't do for us? The answer here is no, we don't. We don't have any gestures at all. Finally, do we need access to the canvas? Do we need to do custom painting? Well, on the one hand, you could probably find a way to create this particle effect using nothing but widgets, but it's going to be much easier and more direct for us to draw these stars with paths, and so we will use a custom, we'll use a canvas, and therefore we want to use a custom painter. Now that said, let me step back for just a moment and talk about us using paths and using a custom painter. You could instead bring in some bitmaps and you could just draw some very small star bitmaps. Nothing wrong with that. In fact, in a certain regard, it might even be more performant because those bitmaps will be cached. On the other hand, if your designer ever wants you to make things larger or changes the overall boundary, changes the nature of the particle effect, odds are those bitmaps that you brought in will need to be replaced with new bitmaps, which is kind of a pain. Another option is rather than literally drawing the path yourself, you could load an SVG, you could load vector graphics. But this then requires that you add vector graphics support just to create a path that what we will find can be very easily drawn and painted ourselves. So that's a legitimate path to go. You could do that, but in the end, it's probably even easier just to draw the star directly, which is what we're going to do in this video. So before we can animate stars, we need many stars, and before we can have many stars, we need one star. Let's go figure out how we're going to paint a star using Flutter with a custom painter. We begin, as we always do, with a demo scaffold that just shows this card with some text. So let's replace that text with an empty widget that I have called floating stars. And when I say empty widget, I really mean empty widget. This is now where we want to do our star painting. So I said we want a custom painter so that we can draw the path. We'll give this container a color. We'll give the right background color, and then we'll introduce the custom paint. So we'll give it a color of, I believe I have a color called track gold. Let's save that. Now we have the right background color upon which to draw our stars. And then the child here will be a custom paint, whose painter will be, let's call it Star System Painter. And the reason I'm calling it Star System is because eventually we're going to have many stars, and that size is going to be as large as possible. Now we need to create this custom painter. So Star System Painter extends custom painter. We will implement those methods. For now, we will always repaint. We'll revisit that later once we figure out when the right time is to repaint. And then here in Paint, can we figure out how to draw a star? Once we can draw one star, then we can draw many stars, and once we can draw many stars, we can animate them. So what is a star exactly? What would it mean to draw it? Well, first let's get the pieces that we need for painting. So let's create a paint. We'll make it black to begin with so it's easy to see. And then we're going to create a star path create the path. And then once we figure out how to create that path for the star, we then want to say canvas draw path with the star path and the paint. Those are our high-level steps. Now, how do we create the path? To understand geometrically what a star is, let's start with something that is not a star, but it's still a very simple geometric shape, and then we'll kind of morph it into a star. Let's begin by drawing a pentagon, a polygon, equilateral polygon with 5 points. And just for ease of thinking about it, let's begin by drawing the point that's straight up in the air and then go clockwise to all the other points on the pentagon. So we will say angle will begin with negative pi over 2. That is, in terms of screen coordinates, that is pointing upward. And, well, for now, we'll hard code the distances, and then we'll come back and parameterize those later. So we want to create a path that begins straight up by some amount. In that amount, we're starting at the center. In theory, we want to start at the center of the available space. I guess we should also calculate that as well, right? So we have center, which is size center with no offset. And we want to move from the center in the direction of the angle, which means straight up by some distance. Let's take our star path and let's move the drawing coordinates. We want to move to a certain x and y. This is the x and y pointing straight up. The x can be thought of as the cosine of our angle. We need some distance still, but fundamentally it's the cosine, and the x is y, is the sine. And then distance, I said we'd hard code it, but let's create a property called outer radius, and we'll make that 100 and see how that goes. And we'll take that outer radius and multiply it by our trig functions here. And even though we won't be able to see it yet, that point, the point right here, if we come over to our rendering, is somewhere up here. It's somewhere just above the center of the available space. And then we want 4 more points to create a pentagon. For that, we will say for I is 0. Actually, we can say maybe 1 because we've already done the first point. Let's see how that works out. Then I is less than, how many points do we want? We want 5 points plus equals 1, okay? Now star path, now we're going to draw a line with our path. We started by moving to a drawing location, and now we're going to create a line to the next point. And what is the next point? Well, it's outer radius times the cosine of the angle, and outer radius times the sine of the angle. But we haven't changed the angle yet. So angle plus equals, well, if it's a pentagon, that means that we have equally subdivided a circle by 5. So that's 2 times pi divided by 5 added to our existing angle. That's the amount that our angle should change every time we come through the loop. Then we create the line to that point. And when we're all done, we're going to say star path dot close, and then we're going to paint it. And center, we should add center up here, I think, as well. Plus center dx plus center dy. And we want that down here as well. There's our pentagon. 1, 2, 3, 4, 5 points. Now a pentagon is not a star. So, but you can see that it has the points, right? It has the points of the star, It just it doesn't look like an actual star. So what's the difference? The difference is if we take the midpoint between each of these pentagon points and we pull it in towards the center, then it will look like a star. And let's prove that. Let's create an inner radius. See, a star has an outer radius and an inner radius, with the outer radius being the points on the star, the inner radius being how you pull those midpoints back in. So for now, let's just say 75. Let's take a guess. And then each time through this loop, we don't just want to draw a line to the next point. We also want to draw a line to that pulled in the inner point, the outer point and the inner point. Now the angle is going to be different in this case. So we could say, for example, let's say inner point angle, that's going to be equal to the previous angle plus half of this difference. So 2 times pi divided by 5, that's the regular difference in angle. We want to be half of that, and that is our inner point angle. And then let's say, and we can actually do this part in one line using the cascade operator. First, instead of drawing a line to the outer point, we're going to draw a line to the inner point. So instead of outer radius, we want inner radius. And then we want the inner point angle instead of the outer point angle. Let's save that. Okay, we're starting to see the beginning of a star, but it looks like our inner radius is not nearly enough. Let's bring that down to 50. Okay, that's better, but we clearly see that we're missing the final step here. So we'll fix this when we get this to, when we refactor this, but it looks like in the final location, after the final iteration of the loop, we want one more line. And that angle is going to be, it's going to be the full circle, so 300, well, so it'll be we could say minus pi over 2, that's where we began our angle. And then we want to further subtract the standard difference, which is this right here. And again, we'll clean this up, but I just want you to see the star. Okay, and there's the star. Now you can see how we got the geometry. We placed 5 points at the outer radius, and then we placed 5 points at the inner radius in between those outer points, and now we have a traditional 5-point star. And you can set the inner radius to whatever you want. You can have it look sharper by pulling those points in more, or you can have it look softer by pulling them in less and having less of a divot. But now all of these little stars that are animating, we know how to draw them. We just need to draw them at the appropriate size, the appropriate rotation and color, and that's what we're going to do right now. Let's clean up this code for drawing a star so that then it's easier for us to draw many stars. Let's create something called, we'll call it a star path template. And we want the ability to create the path for a star with whatever given configuration we choose. Right now we just kind of have one configuration, but we can open that up with properties moving forward. So let's take that code, paste it down here, and let's check some of these properties that we have in here and see if we need to update them. So let's remove the center from this. We will draw our path at the center of wherever the canvas happens to be. We're just going to return a path without any consideration of the origin, and then whoever asks us for this path can then offset it however they want. Say return star path. So the outer radius and inner radius, we will eventually move those into template properties. And then let's see what we want to do here with this path. I think that we can, so we want to clean up some of this inner radius, outer radius stuff. And to do that, I think that actually we want to loop for every point. If we loop for every point, then we don't have to do that weird extra step at the end of the loop. So let's multiply 5 by 2. And again, 5 we will replace, but for right now, we'll say 5 times 2, which is every point. It's like double 2 pentagons. Both of our pentagons are covered here. And then the angle, instead of jumping by an outer amount, the outer point amount, we now always jump by half of that. So remember that here is the angle between each of our outer points, and then we subdivide that by 2 to get the angle between inner and outer points. So then we will say line to angle, get rid of the center part, angle, get rid of the center part. And in fact, looking at this, I don't even think we need to track the angle at all. I think that what we can do in here is take this part here and define it as an angle increment. So let's get rid of that. And we will say angle increment equals that amount. And then down here we can say I times angle increment minus pi over 2. And then down here we'll do the same thing, but for I plus 1. All right, and now let's remove this last part, and we close the path here at the bottom, and then we return it. And in terms of moving to the initial position, we will take minus pi divided by 2. And now in theory, if we come back up here to our custom painter, and we say star path template equals new star path template, we can say star path equals star path template to path. And let's see what happens. Oh, no, it ended up disappearing after all. Okay, so one thing is I forgot to move the canvas. So we want to say canvas. So first we'll save the current canvas transformation, whatever that happens to be. And then we will translate to center dx, center dy. And then when we're done drawing everything, we will say canvas.restore. Now I need center again. Oh, well, it's back, but it's definitely not what we expected. I think, hold on, let's see what happens if we go back to just 5 points. Okay, that's not good. What if we add 2 to I? Okay, there we go. So we do, in terms of the value of I, the reason I matters is because I is being multiplied by the angle increment. So the actual value of I is now important with the way we've written this loop. We want I to eventually be 10. But we are drawing two lines at the same time. One line going out to in, one line going in to out, and therefore we increment I by 2, and now we're back to a star. But okay, crisis averted. We have the star back. And again, what we did here is we moved the drawing location to the center, then we create the path, we draw the path at that location, which is the center of the screen or center of the visible area, and then we restore the canvas for whatever painting happens in other places in the widget tree. But now let's add some properties to this star path template. For example, outer radius should be defined here, as should the inner radius. We'll generate a constructor. This will be a const. And we'll say, for now, we'll just default it to 150, respectively. And then we'll get rid of those. And we'll save. That's going to take a while to hot reload, possibly. But now let's change the outer radius to 80. All right, notice that our outer radius did change over here, which means those values are working as intended. But just for fun, let's also make the point count variable. Obviously, we'll default to 5, and we're also going to assert that point count is greater than 3, or greater than or equal to 3. And then down here, where we have this 5 everywhere, let's change that to point count. All right, and what's complaining about? Okay, this is no longer a constant. That's fine. Save. And now let's change the point count to 6. Okay, now we have a 6-point star. We can have, how about a 10-point star? There's a 10-point star. And we could have, let's say, a 20-point star, and let's pull the inner radius out a bit. And now you have something that might pass for like a badge or something, a little decorative graphic where you give people points or awards or whatever. This is essentially a star. It's just a star with many points and very little difference between the outer and inner radius. Hopefully you can see how powerful this little template can be. But let's go back to 5 points. And now we're back to our 1 star. And let's figure out what we want to do painting maybe more than 1 star, what that means for us with the rest of the clone process. If we want to paint a bunch of different stars at different locations with different, you could say, visual states, it would be nice for us to represent that in an object. Let's come down here below the painter, and let's create a class called star particle. This star particle will have a position, it will have a velocity, it will have a radius, it will have a rotation, it will have a radial velocity, and it will have a color. Now let's make sure that you understand why we have these pieces. The position is the XY that we draw it right now. The velocity is how quickly it's moving in some direction, because on the next frame, again, if we're animating like this video, on the next frame, it's going to have a different position. That new position is based on velocity. Radius is the outer radius of the points of the star, so we can have smaller and larger stars. We have some variation. Rotation, as you can see down here in the video, these stars are rotating, some slowly, some not at all, but there's a rotation to them. And that rotation changes, which is called radial velocity. And then, of course, we want a color. Let's generate a constructor. And this is not going to be const because we're actually going to make changes to our particles. Required. Actually, for velocity, if someone doesn't provide it, we'll make it 0. We'll require the radius. If someone doesn't offer a rotation, it'll be 0. If someone doesn't offer a radial velocity, it'll be 0, but we will require a color. Now, I said we're not going to make it const, and that's because we are going to eventually implement this method here where we update the position and the rotation over time. That's what's going to give us the animation. For now, let's just get these properties working. Now, in addition to the concept of a particle, particles belong to a system. A system is what drives that time forward, and the system holds on to all of the particles. So let's create a star system. And then we will have an init method where we take in a size. We'll call it world size. When we initialize a star system, we want a bunch of random stars, like randomly located stars. But to position them randomly requires that we know all the places they might appear, which we'll call world size. In our case, this is just going to be the canvas size. But we need that information coming in so that we can randomly position the stars. Now, the star system will have a max star count because we need to know how many stars to generate. And I don't know, let's default that to 50. And then in init, we will say for I is 0, I is less than max star count, we need to generate a star, which also means we are going to have I guess we can say a list of star particle, which will be the stars. And then we need to generate those stars. We'll say stars add star particle, and then we need those properties. Now, right now for the color, let's go with, I think I have some gold colors here. Okay, star bright and star dark, that's what we've got. So let's come down here and let's just say star bright. And for radius right now, let's just say, I don't know, 20. And then for position, let's have an offset, which is, let's create a random. We'll say random next int world size dot width, random next int world size dot height. Convert those to doubles. Oh, okay, so yeah, size has doubles. So what we will actually say, we will go random next double times world size dot width. That's a random width. Random next double times world size dot height. That's a random position in our world with a radius, that outer radius always of 20, always with this color. Let's see how far we can get with this little implementation. And we will also, let's track our initialization. So we will say is initialized as false, if is initialized return, otherwise say that we are initialized. We don't want to accidentally generate stars multiple times. And the reason that's important is because we actually need to initialize in the paint method with the given size. So we're going to take in a star system into our painter. And then down here in should repaint, we need to actually check the old versus the new. Turn star system is not equal to old delegate star system. And now we need to actually pass it into our painter. So in our stateful widget, we need to have a star system. We will create that in init state. And we will pass it into our painter. Now our painter needs to actually do something with this. Here in our paint method, we want to move the canvas for every star. So let's move the save call up there because we need to translate multiple times. We also need to initialize our star system, like I said before. So star system.init, and we're going to pass in our canvas size. This will only run the first time that we paint, and then it will avoid reinitializing every other time. Okay, and then let's say for star in star system.stars, what do we want to do? We want to translate to the star, let's see, star.position dx, star.position dy. Then we want to create a template where the outer radius is equal to that star radius, and then the inner radius, we're just going to multiply it by 0.5. And then we can avoid this line by creating the path directly in the paint method. By the way, the paint color needs to be equivalent to the star color because the stars will be different color. So what are we doing here? We're initializing our star system that'll generate 50 random stars. We save our canvas drawing state, including translation. For every star, we create a paint with the right color. We translate to the location that we want to draw the star, and actually we can put the canvas operations together. So paint color, create the star template, position ourselves and draw the star, and then restore the canvas when we're all done. Now it's doing a hot reload, which should fail in a moment because we've changed a state object, and then we'll do a hot restart. But I'm hoping the hot reload ends so I can run a hot restart. Let's go here, let's do a hot restart. Okay, now there it is. We're only seeing one star right now. Let me see what happens if I do another hot restart, if it goes somewhere else. Okay, there's two. So we are generating multiple stars, but something we've set up something incorrectly here, that a bunch of stars are not appearing in our visible space. So let's see what's going on. Okay. It is not after all of the stars that we want to restore the canvas. We want to save and restore on every star. Otherwise, we're constantly adding offsets to our canvas. That quickly takes us off screen. Now we have all 50 stars on screen. So now that we have all 50 stars in random locations, let's add a little bit of variety to what we're generating here. Let's come back to our star system, and let's take the radius and let's go with a random next double times, or what we can say here actually is lerp double. The minimum size, let's say, is, I don't know, 10. The max is 30. And then the percentage in between is going to be random next double. And maybe we need to import that. Yeah, and then that returns non-null. Save that. And I'll probably need to do a hot restart here once hot reload is done. There we go. We have different sized stars. We also want different colors though. And fortunately we have I think color.lerp, linear interpolate. We want to go from star dark to star bright randomly. And again, I think I'll need to do a hot restart to see that. Okay, now we've got some darker stars and some lighter stars. Let's also add a random rotation. So the initial rotation, lerp double, we will rotate between 0 and 2 times pi, 0 radians and 2 times pi radians, and once again we will say next double. And I will hot restart. Oh, we actually have to apply the rotation. So let's go back up to our painter. Let's see, go back up to our painter. And after we translate, we want to rotate by star.rotation. And now you can see all of our stars have some amount of rotation. Now we have the static, non-animated rendering of our stars. This is what we want. The next step is to actually animate them. So the first step, as in similar or other videos that we've done, the first step towards getting some kind of change over time is to come up to our state object and mix in the single ticker provider state mixin. We are then going to create a ticker that's always running. Import scheduler. Ticker equals create ticker. Create ticker. And then we're going to have this onTick method that we're going to define. And we need to make sure in dispose to dispose of our ticker. And what does onTick look like? It looks like this. We're also going to keep track of the previous frame time, because when we actually do start moving these stars, I don't want to deal with the elapsed time. I want to deal with delta time. So dt equals elapsed time minus previous frame time. And then what we'll do is we will say or we'll tell our star system to update with this change in time. Update doesn't exist in our star system yet, so let's go tell our star system how to update. Come down here to our star system, and we will create update with a duration dt, and all our star system needs to do is tell every star to update. So for star in stars, we will tell the star onTick dt, and I guess to match this call, let's have the star also call it update. And then we said down here in our star particle, we haven't done anything for update yet. Before we implement update, let's save, let's do a hot restart because we brought in a new mixin, so hot reload should fail in a moment, and then we'll do a hot restart. All right, now what do we want to do in update? Well, in update, we want to set our position equal to that plus velocity. And by the way, this should no longer be final, and neither should rotation, because rotation plus equals radial velocity. Save that. You won't see any changes, and that's for two reasons. One is that we aren't actually providing a velocity or a radial velocity, and two, we aren't telling the painter to repaint. Let's solve the first problem. Let's provide a velocity and a radial velocity. So where we create our star particles, up here, let's give it a velocity. Let's say random next double times, and this is going to be measured in, well, actually, sorry, I forgot one thing down here in the star update is we don't want to add the whole velocity. The question is, what are the units of velocity? It's nice to think in per second. So let's say times dt in milliseconds divided by 1,000. Then our velocity here is pixels per second, and our radial velocity is radians per second. Now we know what units we're dealing with. So how far, what's the furthest we want to go in 1 second? I don't know, probably like, let's say 1,000 pixels per second as the max. And we know that we only want to move horizontally. So we pass in a vector where only the x coordinate, only the x component has a value. That's velocity. Now let's talk about radial velocity. How many radians do we want to rotate per second? We want this to actually be quite small. So, let's say that we want to rotate maybe at most 1/8 of 1/2 of a circle per second. And we can see how that looks. Now, even if I save that, we still don't see anything, and that's at least partially because we aren't telling our painter to repaint. So let me come up here to our painter. Now, when the entire star system changes, we repaint. But what about when the same star system itself changes? Now, there are a couple ways we can do this, but here's what we'll do in this case. We'll take star system and we will mix in change notifier. And then in update, we will say notify listeners. And then in our painter, every custom painter, the super constructor takes something called repaint, which is a signal for when you should repaint. We'll pass in the star system. Every time our star system notifies listeners, it will trigger a repaint. Save that. Okay, I was expecting that to work, but as always, I have forgotten to start the timer, or the ticker. And for that, we'll need a hot restart. Oh, that went real fast. Okay, so among other things, in our star system, we need to check for any star that's no longer on screen. So in update, we need to cull off-screen stars. We're going to loop from the back of our star list to the beginning. And we're going to say if the offset, if stars I position, and we know in this case we're only moving horizontally. So if the x is greater than, and now we know that we need to remember the width of our world, we'll say world size dot width. Then we want to say stars remove at I. We need to remember how wide the world is. call the, well, we'll say it's late and see if that creates any problems for us. Okay. And now if we cull the off-screen stars, we also need to regenerate any missing stars. Generate new stars. And that behavior is going to be exactly the same as what we have up here. The only difference is that we're going to loop to a different number. So let's take this, say generate new stars, and then let's say down here, generate new stars. I'll paste what I cut, but instead of max star count, we want max star count minus, well, let's calculate that here. New star count is equal to max star count minus the current number of stars, so that we always have 50. And then here we want world size and world size. Let's save. Let's do a hot restart and see if that makes any difference. Uh-oh. Okay, so let's change world size. It looks like somehow we're getting an update call even before we've initialized. So let's say generate new stars. If world size is null, we're going to do nothing. And cull if world size is null, we're going to do nothing. Okay, and you're not late anymore. Okay, so a few things for us to improve here. It looks like 1,000 pixels per second is way too much. That's one thing. Let's try, I don't know, 200. And let's say lerp double. We want a minimum as well. So the minimum speed, let's say, is 10 pixels per second. Maximum is 200. And let's do a hot restart to avoid getting any at 0. Let's try something way smaller. And I'm noticing they're getting faster and faster, which tells me that something in our tick is not working correctly. So if we come back up here to our tick, well, we are not ever setting the previous frame time. Let's do a hot restart. All right, now that's more reasonable. So let's say 200 for the speed. The rotation looks reasonable. You know, and instead of generating these stars in the visible space, seeing them pop in is pretty annoying. So I think we should generate them to the left of the available space. So let's take the position right here. We'll still take the same random value. So any random position up to the width of the available space, but then we're going to subtract the width of the available space. Let's do a hot restart. Okay, so now they're all generating over here on the left with a distribution, and they move to the right. And now we have animated gold stars. Now it doesn't look exactly like what we see down here in the video in terms of some down here might be darker or lighter than what we see in ours, and maybe we don't have quite the right variation in speed, but that's all stuff that we can tweak using the properties that we've looked at so far. So this is where we're going to leave it. I'll tweak this a little bit between now and the next video for the Starbucks app, but in the next Starbucks related video, we'll come back and we'll create this entire little rewards tracker, including what you see when you haven't earned a free coffee yet, and then we can call that particular clone complete. But this ends our work on today's battle in the Flutter Clone Wars. Again, like, subscribe, share, get the word out, and I'll see you in the next battle of the Flutter Clone Wars.